So in this video, I'm going to talk about the differences between traditional data centers that we've seen over the last 30 or 40 years and a trend that we're seeing to hybrid cloud or multi-hybrid cloud architectures. So in a traditional data center, what I would normally do is I would have a request from an engineering team or a line of business that wants a new application. And I would spec out that new application, maybe go find out what the hardware requirements are. I would find space in my data center, and then I would buy a rack of machines specific to that application. This is still going on in several data centers throughout the world today. Um, some of the benefits of this approach are you know exactly what you're getting. Your performance will be pretty close to what they advertise in your software vendor because you fine-tuned your hardware for that specific application. Some of the downsides to this are flexibility. If I want to run a new application, I have to go buy more hardware. That approach has led to slowdowns in deploying new applications or being flexible in your data center to handle different types of things. The new way of thinking about things is what we call a hybrid architecture or a multi-hybrid cloud architecture, where now I'm connecting to different clouds to get different services, whether it's just computer storage or very specific types of services in these different clouds like AWS, Google, Azure, or IBM Cloud. Right? Now, with a hybrid or multi-hybrid, this also means that I can leverage things that I'm doing in my own data center as well, either legacy applications or maybe I have my own private clouds in my own data centers. The benefit of this is the agility to deploy new applications quickly because I'm not buying purpose-built hardware for that. I also can handle different kinds of loads. I can add new applications quickly. I can deploy security across all my applications in one fell swoop. And the thing that helps me get to that level is that cloud stack layer. Instead of deploying software directly on hardware, I'm deploying it to an orchestration layer. And the orchestrator and control layer in that cloud will deploy that software onto chosen hardware. And a really good orchestrator or control layer will keep your service level agreements that you want and your quality of service that you need for that specific application. Now, one of the best ways to demonstrate how this works is a simulator that I wrote that can simulate exactly how these three different layers work together. So in this case, in this simulator, I actually have three data centers and two applications that are running across those data centers. And as this is building out here, you'll see real quick the three layers. Up here on the top layer up here is my application layer. I have two applications, alert and basic annotation. These are two applications that are running. And these applications take advantage of microservices. So in this case here, there's 4 services that are running for the alert application. And then over here, there are 7 services running. And then under those services, I have multiple instances of those services. In this case, I'm using containers for these. So in this case here, I've got 8 instances of this annotation service or ingestion service that's running, and that is my service layer. So this would be your traditional application layer up here. Here's my cloud layer right here. My cloud layer, in this case, I'm creating virtual machines, software-defined storage, and software-defined networking to handle the different types of applications I'm going to run. In a true multi-hybrid cloud, you don't have to have VMs handling these things. You just need software-defined compute. And people get confused sometimes. They think that software-defined compute means VMs. It could mean bare metal provisioning, container onto bare metal, container onto VMs, or just VMs. It could be any of those. A good control layer can handle all those combinations. For purposes of this simulation, we're going to run containers on VMs. As I can see here, here are my containers. and here are my VMs. And then the bottom layer down here, of course, is my hardware layer where I've got servers, storage, and network devices down here. So I can quickly see, I can select on one of these compute nodes. I can see the number of VMs running on there, the number of containers, and what services are affected by those containers running. So pretty cool demo that shows how this can all connect together. I can select a VM itself, or I can select a container and see exactly where it's running, who's affecting it, including any networking or storage that's involved. I can also click on data center down here and see the effects of data center, who's running on what. And what's fascinating about this is I can see that this data center is servicing part of this application, but not the whole thing. In fact, in reality, if I click on this application up here, it's running across all 3 data centers, which is pretty cool. That's what we'd like to see. Now, this is pretty static, kind of boring, frankly. Let's see what happens if I decide to remove a whole data center. Let's say a data center is going out of commission, or I'm doing patch level on a data center. I'm taking it out. The power went out, a tornado hit it, whatever. We can simulate that as well. So I'm going to remove a data center here. This is the data center I'm going to remove. It's going to affect this application here. And as you've noticed, I now have 2 data centers. I've done a vMotion. I've moved my VMs to the other data centers. This works well if you have a planned outage. And my application and containers on my applications are still okay. Everything still works. So you can see that flexibility that we have there that we need. Now, I can also remove just an individual compute node. In this case, I'm removing this node here. It affects one VM. I've moved that VM to this node over here, and my applications can still stay the same. So this shows you that resiliency that you want in your data centers. Now, there's some other things that we should add in here. Let's see how fast I can add a new application. I'm going to add the deep learning application here, and you'll see it pop in here. You'll also see that it will create the new application right here, and you can see that it spans across both data centers. And this is quite a large application, several more containers running, several more VMs involved, as you can see. Now, this is all great. I just showed I can add a new application quickly. It distributes the work across multiple data centers. It creates VMs as it needs to, and I'm utilizing my hardware as best as I can. In reality, my data centers don't have a constant load. So let's add a load onto the system. In fact, in this case here, I'm actually going to connect these applications to some cars. And I'm going to connect 1,000 cars, and of those cars, I'm going to get information from those cars, about 240 kilobytes per minute. And I'm going to say that 10% of the cars are going to get in a crash. That's kind of high, but I want to show some interesting things here. So over here on the right, I can see all the different events going on in my data center. And here are my policies. And my policies are set up to, depending on number of accidents or ingestion level or throughput in my data center, I can scale up or scale down an application. So in this case here, the number of accidents hasn't really affected me yet, but I can see ingestion has, the amount of cars connected and ingestion coming in. So what I need to do is scale up my ingestion application or services, and I have. Now there's 38 instances of ingestion running to handle that load. And if I bring this back down to only 100 cars or something like that, then you'll see that this number will go back down. It will decrease the number of instances, as you can see there. I click on instance, now I'm down to 20 instances of that running. So I can scale up and scale down dynamically. And all this is because of this cloud layer in the middle. It can handle all that load, and it can based off of your policies, do what needs to happen. So I hope this little simulation kind of shows that benefit of the cloud layer. You can find out a lot more, and you can even download the simulator yourself. It's out on Docker Hub, and you can get access through it through GitHub right there. There's the URL for the GitHub. And then also we have a lot of documentation on the use cases of the multi-hybrid cloud and all the benefits out on Read the Docs. So you can take a look at c3.readthedocs.io for more information. I hope this has helped you in some respect, and good luck modernizing your data.